Oh, it looks like I fixed the chatbot. We are going live with plenty of jackhammers in the background, apparently. Looks like we're live on YouTube. Is Twitch coming online? I think we're live on Twitch too. I've been having this bug with the Twitch web client where it says I'm offline, but then if you scroll down, the video preview is coming right in. So that's the state we're in right now. Hopefully the chat is live and I can see anybody who posts messages in there. Yeah, sorry about, well, today's stream might be under somewhat suboptimal conditions. I still have a cold. I had a cold yesterday. I have a cold, somewhat worse today, so, but I checked out some of the archive from yesterday's stream, and it seems like it actually went alright, so, maybe we could do a short stream today and it wouldn't be a disaster, despite the persistent cold. That said, I'm just realizing I should turn on the video recorder. Tuco is actually hanging out down here. I don't know where he went though. He was hanging out on my new box of Kleenex. I'm no longer using Kim wipes to blow my nose. That was the depths I had sunk to, given that I was out of proper facial tissues. But this is a nice view, right? Hi. Let's go over here and start the recorder. Keep an eye out for the cat. Alright, that's better. Well, less of a rough start than yesterday, alright. Oh yeah, coordinate systems. So, yeah, video recorder's running. We can keep an eye out for Tuco. I think he's upstairs right now. Which is, in that direction. Anyway, so I'm still kind of sick. It's jackhammering outside. I don't know if I can stream for super long, and I've already been rambling, but I thought the thing we could try to do today is solve a minor Robot Odyssey related mystery. This is a little bit random, like there isn't really a reason I need to know this, but it's something that had been kind of, you know, poking at my curiosity. So anyway, out with it. I want to know how this game generates random numbers. There's a little bit of randomization in how items are placed in the first level, and I'm actually, I just don't know where it could be getting the random numbers, because the game itself doesn't really have any sources of time it can use with each other. Like there isn't really a good way to get a seed. My theory is that actually maybe it's waiting until you switch from the first room to the second room to actually do the item setup, and it's at that point that it's using some kind of timing, like based on like exactly how long it's taken you from the game starting to making that move. So let's investigate. I think there's an interesting mystery here that we could perhaps discover. Oh yeah, Concrete was commenting on the keyboard over there. Yeah, this one over here is actually, it's been growing on me. It's pretty weird. It's an ergonomic keyboard from this Kickstarter that I backed a while ago, kind of local to me here in the Oakland area. It's called Keyboardio, and it's sort of like an open source Kinesis style ergonomic keyboard, but it's made out of milled wood and it's open source firmware and hardware. It's a really interesting keyboard, and it's been a bit of a learning curve to get used to it. And I still use other keyboards also, like over here. So, like I'm over here at this desk on a normal keyboard. I've also got a laptop with regular keyboard, so I don't plan to like exclusively use split keyboards, but I think using that has helped me kind of train myself away from some bad habits, and be less hard on my wrists, for example. So yeah, working on it. Still a bit of a challenge getting used to the new layout, especially the modifier keys all being in different places. It's been pretty weird. So yeah, I'm also going to use this new gamepad support. So we implemented this on the last stream, and it's still, like, there's no fancy remapping or anything, but you can basically use gamepad for this now. You can use, if you have the standard W3C mapping, which for me is working with the Steam controller and Chrome, but there are probably other combinations of browsers and controllers that'll work. This is just the one that I happen to have here for testing with. The code works cross-browser, but one problem I ran into is that the browsers seem to all have different levels of support for remapping various vendor control pads to the standard layout. So if you try this with a different browser, you might end up with the wrong joystick mappings. If you try this with a different controller, you might end up with the wrong joystick mappings. So that's still a problem we might end up needing to solve in the game's UI, but for now, you either have to just deal with it or like solve it using some other remapping utility. Like for me, if I wanted to run this in Firefox and Firefox didn't support the mapping for this, I could use the utility that comes with the Steam controller to redo the mapping. So got D-pad for just like making single movements, and then analog stick. The analog stick is still like scaled a little bit weirdly. I think I need to tweak the responsiveness. Like I still find it frustrating to make very fine movements with the analog stick, both in the game proper and in the menu, but I think the problems are separate. So anyway, I'm gonna mute this because I'm tired of the cutscene music. I think it's kind of loud the way it's set up right now. So if I go into Robotropolis, place the cutscene, I skip the cutscene, and then I end up here. So at this point, the game has seen no user input. It doesn't seem like it should have any sources of randomness. But it could be starting a timer now and measuring how long it takes me to react to this wall of text here and actually move into the proper start of the game. But, you know, I've got these robots moving around. The first thing I noticed here is that there's a key that you need to get out of the room, and the key seems to show up in a different robot randomly. So let's take a look. You know, it could also be something like maybe there's a chance when you walk into a robot that the key spawns in it or something like that. You know, so like I don't know whether we should expect, like, when the level first loads, whether it's generating some random number somehow, or maybe when the level first switches rooms, it generates a bunch of random numbers and then sets all the items right there, or whether it's more of a continuous process where maybe every time you enter a room there's a chance that it spawns one of the missing items until you have a full complement of the game's items. So let's see, let's just try one trial here. Let's walk around and see where the key is. So it's not in the red robot. Oops. Oh yeah, let's make this easier and not have the robots walking around also. So the key's in the blue robot. So I'm just going to write down that I walked inside the red robot and then the blue robot, and then it was in the blue robot. Alright, and then the next thing I'm going to check is where the black crystal spawns. So that's another item that we can look for. So the other thing I'm going to do is I'm going to make this a little easier for us by turning on a bit of a cheat code that helps visualize the items. I'm going to get the latest version of this from GitHub, but actually, let me just show you where this is online, because it's easy to get to online also. Sorry I'm so sniffly, by the way. Oh yeah, yeah, I just saw the rest of Concrete's comments about the keyboard. Yeah, being an input device jockey to kind of save your body and your wrists, like, yeah, it seems like it's kind of necessary at some point, because, like, I don't know, I've been typing for enough years that it, like, just starts to have a toll on your body, and you just have to, like, start to worry about how you're treating your joints. And yeah, I was a little skeptical of the split layout at first. Like, it seemed cognitively like a thing that would work really well when I think about like how I type and like especially just like how I want to hold my body. I feel like I've got like kind of wide shoulders and I naturally kind of have to like tilt inward to get to a normal keyboard, and having like a wider set, you know, like that might be nice too. I also just find that I would like reach across the keyboard. You know, I had like a bunch of bad habits that actually moving the two halves separately kind of forced me to break. So, like, with the keyboard halves just placed, like, right next to each other, that was alright, but then I tried swapping out the cable for the longer, or a different... So one thing that's cool about this one, it uses a standard, like, Ethernet cable just to connect the two keyboard halves, so you can put them pretty much as far apart as you want, but I'm just using a short cable, and just placing them kind of far apart in the desk, and that actually feels really good. Now it's kind of making me want that on other computers, whereas previously I was kind of dreading having to type on that keyboard. Oh, the tea is really good. I should remember tea when I'm sick. Yeah. Alright, so what I wanted was this file in Notes. So this is the source code repository here. Notes just has like some extra stuff that isn't necessary to build the game, but it kind of goes with the project. So this is just a fragment of code that you can paste into the browser console, and it'll install an event handler. Sort of. It just kind of monkey patches the this onRender frame function that's normally part of the engine, and so it calls the original onRender frame. But then it also calls this update obj for all the possible objects, so all 256 of them. And this takes each game object and kind of copies some of its state into an HTML div in the DOM. And so it's calculating the position based on the object position on the screen. If it's not on the current room, it's hidden, and it puts some text on the object. So it's kind of like a little visual debugger. Right now it's not actually part of the game, it's just a little tidbit that I was finding useful sometimes. And so you can install that by pasting it into the console. And now you get this. That's not the right controller. So yeah, this also makes it pretty obvious which objects are sprites and which ones aren't, I guess. So like these little connectors that change colors are sprites, for example, but the battery and the switch over here, sorry, sprites and objects, I've been trying to use those terms more consistently. What I really meant to say was object. In this case, a sprite is just any 7 by 16 pixel bitmap, really. So there's a table of sprites. Every object has a sprite associated with it, but the sprites are also used separately, and there's kind of an arbitrary mapping, so you can have the objects point to whatever sprite you want. And so these are objects on the screen, but for each object it's telling you what sprite it's associated with, what color. And this is all in hex. So this is object 54 with sprite 16, object 55 with sprite 34. So sprite 34 is this shape. So sprite 34 says it's like an up arrow, basically. And 55 indicates kind of like the memory address of this object. So there will be code that knows that 55 is the left, or the, you know, the lower bumper, and to change its state when the robot bumps into stuff. So, this will make it easier to see the invisible crystal. Oh yeah, so there's also, it would be nice to have this continuously print what room I'm on also. I think the position of that one chip is randomized also. So I also want to make sure to note down the object numbers here. So E7 is important. So many circles, yeah. There it is. And then the black crystal is number 4. And it's in the NH room. Okay, let's reset the game and see what's different. Oh, this might end up kind of crashing badly when I re-enter the game and the memory addresses are different. I mean, if I re-enter Robotropolis, I think it's fine, because the memory addresses will be the same. But if I were, for example, to go into the lab or the tutorials, the addresses will not be the same. And it'll probably crash or just display the wrong things. Oh, but it's going back into the cutscene, and so it crashes. Yeah. That's also a problem with the code that we just pasted in. Oh, yeah, go away. Go away. I've got an unclosable dialogue and I can't find my text editor. Today's going fine. Okay. Let's put that in once we're actually in the game. I don't think my terrible script here is robust enough to handle going through the menu system. But here we go. Now we're back. Okay, so different. Let's go into the blue robot first. Why not? Oh, now the key's in here. So that's the same place. This is... OXFA. Let's reboot the game and just like quickly, without going through the cutscene. Just like that. Is that reproducible? Does that always show up in the blue robot if you walk in the blue robot first? I know I've seen it in other robots. It's not that it's always in the blue robot. Okay, what if you go on the red robot? And the white robot? Okay, so I wonder if this has to do with how quickly I'm moving between rooms. Let's move maybe slightly slower. So what about now? So now it's not in the blue robot. I bet the object cycles around. Okay, it's in the red robot now. Do the objects randomize again if I go back to this room? I'm wondering now if there's just a script that says, when I'm in this room, randomize the objects. So... okay, it's in the red robot. I assume it would kind of lock that out after you've had a chance to interact with the objects. Okay, well, we've got some object IDs and some hunches. Let's see if any of this matches up with what we can see in the disassembly. Oh yeah, Concrete says they realized Scanner is kind of a Cylon. Yeah, kinda, I think so. Scanner was always my favorite robot as a kid when I was playing this. I need more tea soon. Oh yeah, Station 240 says some computers from this era used VSync as a random number generator. Yeah, quite possible. I mean, the way the graphics from this was implemented, they never synchronized with the vertical blanking. It was all just cycle timing. So I don't think the game really made any effort to synchronize with the graphics hardware. Like, there weren't really any other time sources that I can think of, except for just some really minor ones. Like in the menu, there are some time, some like real-time clock-based delays. Okay. Let's just minimize this. Is this still stuck? Okay, this is the menu that we were looking at last. Let's go to the main game binary. So, let's see if we can find that key. So first, let's look for the world data. I think I've already labeled that. Something that starts with world. There's world file name. Did I not label it in this binary? So the other problem is I've done a lot of reverse engineering on, say, the tutorial binary and the lab binary, and a lot of the like actual game logic like this just isn't in those binaries. Alright, so where is the world data? I think the easiest way to find the world data is to look for where it's loaded. So here's some world strings. This is just copying the file names around. Here's actually loading the world file. Yeah, I think this is the actual world data 2AC. We can actually cross-reference that against what we're seeing at runtime. Or, actually, we don't even need that. We can look at the generated code just to verify that that's what my Python script came up with, too. Yeah, world data at 2AC. This was generated by scanning the code for some patterns that we know to look for around world data access. But yeah, so this is the beginning of the world. You can break this up into the object tables that we care about. I think the easiest thing to look for would be the room number table. Oh, I'm just so congested, sorry. So this is the linked list. Next in room, then sprite ID, color, room. Let's call that world data. That's 2AC, 3, 4, 5AC. This is also going to be the room ID of the player because the player is object 0. We can see that it's accessing a lot of these individually. So my sticky note here tells me that the key was object OXFA. A6. There is a reference there. So this would be the key object room ID. Huh. This is a read. So this might be more of the checking to see if a key is in a lock kind of a thing. This is interesting. This might be related. Let's look at what this is writing to. Is this just way up in the middle of nowhere? Is that anywhere near the game's state? Yeah, I don't know what this is yet. Is this the right level? No. Yeah, I bet that's something for the ventilation, or not the ventilation shaft, the force field puzzle. Because that's checking the key room number, but it's in the wrong main loop. Like, it's in the computer room main loop. So we might not be seeing a direct cross-reference. It might be that there's like a table of objects that get moved around during startup. One thing we could do is... Honestly, one thing we could do that's really easy is to just have a little loop in JavaScript that's just printing out this value so we can see when it's being updated. And if it is being updated when we think it is, we could pinpoint that code by adding a binary translation trace. Which requires recompiling it, but that's easy. Because I've already got it set up. And we just have to add some code. So let's do that JavaScript thing. You know, one thing I could do is just use the same like DOM-based debugging thing, but show objects in every room. Let's try that first. That actually sounds nice and easy and maybe useful. Okay, so that's all the objects in the game. I think the one that's moving back and forth is the Dalek in the hall outside. But otherwise I don't see anything moving. Let's reset the game because it might have already locked in the positions. So there you can see the robots bouncing around. I'm going to turn off the remote to keep those from moving. There's something flickering down here, but I think that's a crystal flashing between colors. Okay, let's narrow this down to just the objects we care about. I'm gonna make a new little file here. Okay, I'm gonna show all the objects in this case, but I'm only going to call this for the objects I actually want to see at the moment. Okay, just those objects. Okay, so E7 is chip 1, FA is the key, 4 is the black crystal, and then I'm just showing the player just for completeness. Let's display the room number too. Okay, let's maybe just focus on the key. So that's FA. Starts out in room 9. It just changed rooms as I walked into the red robot. Yeah, let's try to watch that again. So it's R equals 9. So so it starts out in the red robot always, and there's a chance it leaves. Like that. That's pretty weird. Okay, yeah, let's try to do a memory breakpoint. I don't have like a real memory breakpoint system, but I can recompile it with a trace. Oops. So put the patch in there. Oh, yeah, I actually want the value in that pointer. Oh, now I've got to remind myself how to do a stack trace. I think that's what I want. G.stack. There's a question about what the noise is. It's a bunch of construction stuff outside, and there's a question about why I'm doing this. I'm just curious how the game works. I don't really have any intention to change anything about this part of the game. I just wanted to know how it worked. So many build steps. Did it actually work? Whoa. I don't know if that was what I wanted, but... we just got a stack trace upon walking into that robot. Okay, well, that's not a ton of info, but that's some clues to take a look at. So those stack traces are coming from this little chunk of code, which is just looking for any writes going to this offset. I Oh, actually, I hadn't actually finished writing this. So what it was actually doing here was just giving us a stack trace when I changed rooms. So we could use that to find the room change handler if we wanted. But actually, I need to add an offset to find where the key is moving. So, care about this at 300, and so I think we do actually want to look at the room, and then the key is FA, 3FA. Let's try that again. Sorry, I should have just done that right the first time. Yeah, so like just to be clear, like this is already working. I'm just hacking on this out of curiosity. You can just go to robotodyssey.online and play this now, and it should work. Let me know what you think. The GitHub issue tracker might actually be useful to use at this point. For a while, like, I don't know, it's like there's still some very obvious problems. Like, for example, like there's some stuff that I mentioned on the README as like this just needs doing. So like if you put those in the issue tracker, that's not going to be amazingly helpful, but if you have like something new to add, then the issue tracker is a convenient place to aggregate that kind of stuff. And better yet, if you have code, then pull requests are certainly welcome. So then I was opening this up in an incognito window just to prevent caching. So this does use service workers to cache pretty intensely. So okay, no traces yet. So according to our theory, if I did this right, we'll see a trace potentially as soon as I walk into the red robot. If the key is not in there. It might just be in there. The key is not in there, and I got a stack trace, which is consistent. What happens if I walk in there again? No stack trace. In blue robot, nothing. And in the white robot, there's a key and no stack trace. So this looks like something that moves the key around. So what's going on at each of these addresses? So that last one is 767 in the code segment. Oh, that's not what I wanted. Oh, okay. So 767. We're not getting a full instruction pointer here because just because of how the translation's done, we're just getting markers for when a function was entered or exited. So if we wanted an actual instruction pointer, we would need to modify the tracing infrastructure a little bit to keep track of what instruction we were hooking, which wouldn't be a big deal. I just don't think it's actually doing that right now. I could be mistaken. But anyway, this function's pretty small, so... or is it? No, it isn't. That first section was kind of small. So 5AC is the world data. AC is the beginning of the room table. It's 10 AC. What is 10 AC? It's past the end, is it? No, it's in the tiles. Is it actually reading the room data? Oh, this is interesting. Okay, let's get a little more context for where we are. It's a bunch of calls. I wonder if this is more of a collision detection utility. But this was the function that we were seeing actually modify the position. Oh, you know what? I think this is a general utility to move an object to a different room, including anything it's carrying. Because this is the linked list of objects in a room. Actually, I don't know if it does carrying, but it definitely seems like this is dealing with the linked list at least. So we've got an object ID, and this is the new room. I don't know what it's doing here with this is the data for the room. It's almost like it's trying to find a blank spot, but okay, let's call this object change room. So where did this come from? 6FB1. This is just a wrapper that takes parameters. Object in DL, room in CL. And which of these? 6EAF. Ah. FA is the key. What is going on here? Yeah, we've got some kind of counter here. This one C40F. Why do we only have 3 robots in here? Oh yeah, because like, these are the 3 robot rooms that the key can be in. Okay. Thought I saw that counting to 4, but it must have been counting to 3. Yeah, so when it's 3, it rolls over. So it's either incrementing that counter or it's moving the key. So I want to name this function. Is this just about the key, or is it also moving other objects? Oh, what is going on here? So what is 7AC? Oh, this one keeps closing. 7AC is the Y coordinate? Is that right? Yes, that's offset 500. Are we only changing the Y coordinate here? The X coordinate would be right below that 6AC. Yeah, here's the X coordinate. Oh, here's another object movement. Okay, the DL E7. This is chip 1. This is the black crystal. Yep. I'm gonna call this move randomized objects. I think this is just called in the middle of the game loop somewhere. Yep. So these are the main game loops. This is like the main function. It branches off per level. So I assume this is just the first level's main loop. Yeah. The other levels have like a load overlay thing going on, but this one just starts out right away. See, like these have these world overlays. But the first level loads somewhat differently. Oops. Yeah, and it seems like it's just in a non-conditional part of the main loop, just in this big mess. There's a lot of stuff this game does in every frame. Alright, so this is it. This is the function that contains all the randomizations. This is at 6EAF in game.exe. So, what is causing it to exit here? Is this 1BFO2? Is this like a flag that causes this part to happen once? Looks like that's the only places this is being used. I'm gonna say have randomized objects been placed, is what this is. Alright, so if randomized objects have been placed, if they've not been placed, so if this is 0, then we jump over here. If they have, then we're done here. Yeah, in this case, we're just checking the current player room. So what is room 28? Is there something special about room 28? Let's have our debug script again. Wow, this one really needs room number. Clean that up a little bit. Okay, now these all have a room number as well. So this is room 2. This is room B. This is room 9. This is room A. This is room 28. So what was special over here? Yeah, this is room 28. So yeah, like I think we are randomizing the items while we're standing in this room somehow. So there's an item randomization counter that just cycles as long as you're standing in that first room. I'm gonna have to look up what CMC is. I feel like I've downloaded this enormous PDF on this computer before. Alright, this one's easier to find. I guess I could also look at my translator because I've had to answer this problem or this question before. Oh, complement carry flag. It swaps the carry flag. Right. Yeah, complement carry. Okay. What is that for? Complement carry and then jump if not below. That's strange. I think this is just sort of a strange way of writing it, but they're incrementing this counter and rolling it over to 0. So does that mean that there are 3 different places the key could be, and also 3 different places that all the other items could end up? Where is this? It'd be great if we could actually display the value of this counter. So this is in data segment C40F. Where's our data segment? That's 100. So D40F should be the linear address for that. So this is not get game memory, which is like more of a structured representation, like a world and circuits. We want, I think it's just called get memory. This is just the 256K of emulated DOS memory, basically. So that should be D40F. Let's reboot. Oh. Yeah, so it's oscillating between 0, 1, and 2. It probably is cycling per frame, right? I can add a terrible hack to just print that every frame. So every frame that should print out the item randomization counter. So in this case it's not ticking because I've loaded from a saved game. Let's reboot. Actually, I can, since I'm not using the structured data, I don't think this is going to crash. I could reboot with the menu. Yeah, it's ticking exactly once per frame. And it's still ticking. And I think we've established it stops ticking when I enter any of the robots. What if I go over here? Oh, it stops if I go over here too. So does it keep running only in those first 2 rooms? That's a decent amount of entropy, you know. So here it is locked into that room. That's cool. So yeah, so that's the very first room with the intro text. And then this room 2 is the second room, I think. Let's put this debug script back on. Yeah, this is room 2. Little r equals 2 on all the sprites. I'm always losing windows on 1080p. Oops. Don't crash, please. Ah. Excuse me. So this is actually in the first or second room. Okay, and so it locks this in as soon as we move to a room which isn't one of those first 2 rooms. So I assume that if this is called before the sprites render, then effectively the very first frame where you switch rooms, it immediately moves the sprites, and then before you have a chance to see them, they are in the right spot. I think that's what we end up seeing. Oh, I'm sorry. Lee on Twitch chat says they're sick as well, but wishes me to get well soon. Yeah, get well soon also, I'm sorry. Maybe it's that time of the year for some folks. I think I'll need to refresh my tea soon. Okay, so this path is pretty straightforward. We're just cycling this counter. Oh wait, actually there's another counter here that has a different period. Okay, this is a little more complicated. So maybe this is just a key randomization counter. I could just label them by period. It's not clear to me why they would need 2 separate counters if one of them is perfectly divisible by the other like this. As I would think that randomized period 3 would always be period 6 divided by 2. Unless something else is going on. And then this stuff, what's this going on? What is going on here? This is running every time the counter increments. 2 of these calls to this sub 21 CDD. Does this show up anywhere else? A lot of places. What are 6 and 2? This could be some utility that's taking a parameter in via AL and returning it via AL. I don't know what these would be either. That's being used to compute a table index over here somewhere in positioning the black crystal. Oh yeah, I'm curious about this. So 21 CDD. So 0 is a pass-through. Like if 0 just goes right straight through this function. It's like some kind of division utility or something. So I don't know what this value is. We're putting this in a byte, shifting it left, XORing it by itself again, shifting it left twice. Is this like a simple linear feedback shift register kind of thing? I wonder if this is a simple random number generator in the game. Like where else would this be used? Well, so it looks like we're always running 7 iterations of this. And if this is a random number generator... Right? It looks like this might be a random number generator state. What does that look like if we just look at that memory? 4AD9? Yeah, interesting. This is a random thing of some sort. It's like a pseudo-random number generator register, maybe. So like what this is doing, it seems to be taking this byte, shifting it, XORing another copy, shifting it 2 spots, and then what are we doing here with this internal number here? Rotating it that once. We're rotating that once per go around. This one's initialized to 1. So it's like every time through this, oh yeah, actually this would be the current bit. I think all we're doing here is using this to periodically, like every 8 invocations, to generate a 1 bit in the carry, which gets slid in through this RCL. This is not a very good random number generator if that's what this is supposed to be, but I think it's supposed to be a random number generator. I mean, it doesn't need to be very good probably for the kinds of things it's being used for here. So then this calls that 7 times so that the phase of that 8-bit shift register kind of walks around by 1 bit each invocation. I think that's maybe the intention. So then this is where things are getting more confusing. So up to this point, this seems like maybe just like a basic, not very good random number generator that you would call and then get a result in AL. But the only place we're seeing this used now is in this function. And this seems to be something where you call it with an argument in AL and then it returns. So maybe this is something, oh, is that intended to be the maximum number that this returns? I think this might be intended to be a random number generator with a limit. This does not look fair. What is this intended to be doing? So we're calling this generator, it gives us a random byte. With that single byte, now we enter this loop, and we check it against that max, and it's like, if it's good, we go through here, if not, we subtract the maximum. So this is like taking a modulo, but I think this might be faster, or maybe it was just easier to implement for their cases. Modulo division can be really slow, especially on 8086. But this is, I think, designed to be a random number generator with an upper limit, but this is not a great way to do that, because when you do that modulo, like for example, let's say you have that limit set to, 192, and you've actually got numbers between, so you've actually got numbers between 0 and 255, but you've set a limit at 192, so what's actually going to happen is that upper half of the space above 192 is going to kind of fold back down, and because that half is not the same size, you'll end up with different probabilities. So the space between 256 and 192 is 64, so that actually would be the only, so it's like if you have 256 different slots that you can kind of put your kind of winning number in, I guess. You've divided that unfairly so that so that the lower 64 output slots, because you've kind of chopped off everything above 192 and kind of pasted it back on. If it had been an even split, like if you tried to set the limit to 128, because that evenly divides into 256, then you end up with that upper half like perfectly matching. But yeah, it's for smaller numbers, like it's going to become less unfair. So I'm guessing that they intended this to be used for numbers much smaller than 256. But yeah, this is not great, but it's nice to know how it works. So I'll call that random number with limit. And this is used in a bunch of places. Okay, so I'm going to label these again according to how they're generated and how big they are. So these are cycling with a period of 3, of 6, and these are using the pseudo-random number generator with a limit of 6 or with 2. I think these are all going to be used for stuff in this function. Yeah. So it's just like spinning these numbers continuously and then locking them in as soon as you walk into something that is not one of those first two rooms, and then running this procedure to set all the object positions. So we've got this randomized period here, which turns into a room number for the key. We've got this random number generator, which turns into an entry for this lookup table, which then goes into this byte. Not sure what that is. B6. This is changing. What does 6A say? Oh, that's the X coordinate. That's kind of weird. I think these are like the room numbers that the black crystal could end up in. Oh no, those were the X coordinates for the black crystal. So it looks like there's 6 randomized locations for the black crystal. So we have these tables of X coordinates. Room numbers. Room numbers are up here. Cool. So 6 different potential locations for the black crystal, randomized. There's chip 1. Does chip 1 not change rooms? Oh, the black crystal and the chip 1 use the same room table. These might just be all 6 rooms in that bottom section of the sewer, but then different X and Y locations. Well, yeah, so if you wanted to highlight all the possible locations that those appear at, then this is your data table right here. Rooms, XY, XY. Anything else here? So black crystal, chip 1. There's the key. So yeah, what's this stuff? So this just like flows right into this other function down here. So object is in DL. Room is in CL. X coordinate is in AL. I don't know why we're setting DI. I'm going to ignore that DI for the moment. Ah, there's some more objects moving around. So this is the key. Let's notate the key, but then there's something between the key and chip 1, I think. This. This has only got 2 different states. It's either 0 or 2. And that's for indexing into this table. I don't know what that table is. This is the table of object IDs. So that ends up in DL. This is a table of object IDs, and this is a table of indexes into that table. Also, are we moving the key? I think we're just changing the room on the key. Yeah, I think the key is pretty simple relative to the rest of this. The key just gets a new room. Alright, what's in this object table? How big is this object table? So this number comes from this table, but we increment it down here also. So I think this is a 4-entry table, 0, 1, 2, and 3. That kind of makes sense. That's a randomized object ID table. Let's make this 4 entries. Did I just completely mess that up? I think I just converted everything into an array. I think I'm gonna have to revert that. Not the array I wanted. It'd be cool if this program had undo. 2 elements on this array? 4 elements on this array? Okay, that's what I wanted. I don't know why I went so badly before. Okay, so do I know anything about these objects? F6 and 3 are just in there twice, but it looks like 0 and 2 swaps the order, so either it's F6 and 3 or 3 and F6. F6 is shape 1, which is pretty generic. Yeah, let's poke around in the game. Okay, object 3. And object F6. What rooms are they in? Rooms 34 and 35. Let's just put the player in that room. Oh! Are the magnet and the crystal randomly swapped? So object 3 is the magnet. Let's write that down. Okay, and the other one was F6 in room 35. Yeah. So F6 is the crystal. Or one crystal. There are multiple crystals. I listed these as shape because they're used in kind of a generic way. You can change the objects in the lab at least. Okay, well that explains it. Crystal magnet combinations. Crystal magnet order index table. I don't know if that's more helpful, but okay. So I think that's pretty much all of it here. We've got, it's using that counter with a period of 3 to pick a room for the key. I should label this table too. Yeah, there's the table of rooms for the key. It's just the 3 robots. Oh, we got some more tables here that I've not labeled. Oh, is there more stuff down here to deal with? This. It's just hard coding the Y coordinate for the crystal and the magnets. Oh, and I already labeled this before I had to reload my IDA. Yeah, so it's just got these two positions, and I think it's, you know, it's treating each entry in this table as like the object that goes in position 1, then the object in position 2, etc. So it's like putting them in a particular hard-coded X, Y, and room number, and then increment the index, and then do the next one. This is a hard-coded Y offset. This is a hard-coded X. Or sorry, this is, yeah, that's an X. This is a room number, and that's chip 1. Yeah, that's all there is to it. No more mysteries here. Okay. Maybe I'll make my little demo here more complete, and then it should show all the randomized choices. This one's kind of far away from the rest of them. Let's give these better names. Oh, saving this might have been redundant. So this is where that actually comes from. Oh, what is this one doing? Right, period 6 is chip 1. This kind of seems like the sort of thing that would be useful to understand if anybody was going to speedrun this game. Just, you know, something I think about occasionally. I want to make some notes on here about how these are actually randomized too. Okay, so objects have been placed, key position, chip 1 location, crystal magnet order, and black crystal location. Alright, so now they're jumping all around. And so I'm printing this once per frame. You can see that the key position is cycling, the chip location is cycling, but with different period. It seems like the key position should always be the chip 1 location divided by 2. And then the crystal magnet order is this kind of pseudo-random stream here. And then the black crystal location is this other pseudo-random stream. Still randomizing. But as soon as we go to this room, no more random. So is it possible to deterministically run this? Whoa. If you hold down a key that is not space, apparently it will not actually skip the cutscene, but you'll activate this feature in the engine which increases the speed if the keyboard buffer is falling behind. That's what just happened. So it does seem like it would be pretty tricky to completely deterministically get through this part of the game, because you've got to get not just through there, but like either around both of these obstacles or into a robot. And yeah, that's tricky. I think for like a human speedrunner, it would be pretty difficult to get the randomization set up perfectly, but maybe there's a trick for it. So I think this part is kind of figured out, but there's still a bunch of other places where that random number generator was being called. I'm kind of curious about that now. So yeah, random number with limit. What's all this other stuff, right? Like, where else does this game need random numbers? This game doesn't strike me as something that requires a lot of randomness. Three and 5. have no idea what's going on here. I don't know if this is it, but I was noticing some teleporter related code, and the teleporter has like a sparkly effect that might be done with a pseudo-random number generator. I also wonder if this is related to any of the like robot animations. So there are only a couple of functions here. There's this one where it's called a lot. Oh, you know what? I can think of a couple of places where we are using this. Like, there's a spot in the computer center. There's like a janitor robot that will pick up objects that you leave in the hall, and then it barfs them back out in a randomized location. So I could see this being used for that. What are you? This is some graphics code. I feel like this is probably something that's patched out because this is like frame buffer related. Whew, yeah, this is getting a bit into the weeds. What's going even on here? So one thing we could do if we wanted to use some of these translation tools to help us is to actually add a patch that anytime this random number with limit gets called, we print a stack trace and maybe print what the limit is. That would be pretty easy to do, actually. Let's remove that experiment. Here I actually just want a hook, not patch. Patch replaces the instruction, hook adds some C++ code. In this case, I don't want to change what's going on, I just want to add some C code. This is at 492D. Okay, so I'm adding this bit of code to the game binary at this location right here. It's just going to print a stack trace and then print out what the RNG limit was. And that'll come out in the JavaScript console. Let me fill my tea. Be right back. Oh, did I just get the dot and the arrow backwards there? Okay, I found my cat. He looks extremely comfortable. He's asleep in a pile of fresh laundry upstairs. Okay, so right now we're getting a bunch of RNG calls with the same limits of 2 and 6 because we're in that like early randomization stage. Let's see if we can get past that. Okay. Let's clear junk out of the console. That's weird. This is not related to the randomization of the level positions. There's just something else going on that is calling these functions a lot. Does it need them for some of these robot animations, I wonder? Let's try putting the robots on different screens. So, oh man, the console gets so laggy sometimes. So nothing on the screen. Lots of stuff on the screen. Maybe it's this room. Really? My suspicion is that it has to do with drawing some of the robot animations, but I thought it was going to be Sparky, but I guess Sparky is just palette cycling, right? Is it checkers? Is checkers actually randomized? Yeah, I don't know, so we're getting 3 and 5 limits, but basically the same stack trace. Well, let's take a look at that. It's extremely verbose here. So 492D is the random number with limit itself. We're looking for a caller at 48FE. Okay, and that's why we're getting a 3 and a 5 in the same call stack. We're using both of those as table indices. Well, let's see where these go. All over the place. Really? A lot of places are writing with this variable. I think this is sprite rendering. I should know these though, like I actually have like addresses for all the sprite and graphics rendering functions. Oh, where's my graphics patch? C9SM203. I think this is the sprite renderer. Oh, no, it isn't. 7203E9? Oh yeah, it's this jump. Yep. So yeah, this is not really annotated in this binary because I was reversing this in a different binary, but this is stuff I'm pretty familiar with. There are global variables that act as drawing parameters, and then this is like video draw sprite. Yeah. Can I get actually just the parameter addresses? Actually, if I just read the generated code, I think it'll have those values. For the right binary, at least. Yeah, in decimal, even. So this was X. Okay, sprite pointers. Okay, so we got some drawing stuff labeled. Where were we with that random number stuff then? For AFE in the code segment. Yeah, so it's picking a random X and Y. So it's choosing a random entry from this table, a random entry from that table, adding it to this base. This table has 3 entries, that table has 5 entries. And these are odd numbers only. That's interesting. What? This is a wrapper around draw sprite for what reason? Alright, well, this is pretty much the point where we can figure out what's going on, because this is a pointer to the actual sprite data. So we could draw the sprite if we wanted to. That's not much of a sprite. So the sprite is this set of 16 pixels. It's just like a square. 6 is 2 adjacent 1s in binary. So it's 2 bits horizontally and then 2 bits vertically. So it's a little square. This could definitely be drawing the effect on the front of checkers. One other thing we could do with this translation, this is not necessarily a good idea, but we could basically wrap this whole function in JavaScript, and then we could just like add modifications to that. Like we could try replacing the returned value with something different. Yeah. So this would still be in our experiment in btgame.py. So I think this time I want to include scriptin.h. Excuse me. I'm just going to replace this with a call to some JavaScript code, I think. Can I do that? I'm used to passing values to JavaScript. How do I pass them back? Yeah, so I'm used to this thing. Oh, there we go. Asm int. That's exactly what I want. So this will be a wrapper around this little smidgen of JavaScript which calls a random function which I'll have to provide. Let's just make this clear. This is my random. We're going to give it the limit, return the value. So in this case, I'm going to switch this to patch and hook. I'm going to replace this with a ret. And then I'm going to have the C code modify r.al. And no more stack trace. This is, I think, basically all you need to override a 16-bit function with a JavaScript function. Let's see if that builds. So in this case, the game is going to crash until I supply that myRandom function, and the original code is no longer going to be accessible. Instead, I'll just have to write a replacement that does something, and I can experiment with that something, with what that something means. Oh yeah, hot serve is what I want. Let's, oh, thanks for the well wishes, folks. Getting sick always sucks, but at least it's just a cold. I think we can check the translated code. Yeah, so there's the code we just inserted. So this used to be the random number generator, but instead we've stubbed it out with a return, and we're just modifying the AL register. In this case, r.al is aliasing this local register structure here. All right. All right, uncaught. So myRandom is not a function. Let's try writing one that always returns 0. And we have to call resume main loop after an exception. Alright, so we're getting calls. In this case, I'm expecting those because of the randomization. So in fact, if I set up that other script that shows us the current randomization results, we should see it being stuck at 0 right now. Yeah. So these two are cycling, but these two that are based on the random number generator are stuck at 0 now. Oh yeah, checkers is no longer as animated as they usually are. Look at that. So the black and white pattern is not random, but the motion of the little colored squares requires the random number generator. So this is continuously scrolling here, so my console is going to start to bog down immediately. But every frame we're getting all of these calls. If I disable the randomizer by going to this room, we should see fewer. Oh, so now we see none of them. If I go back to this room, we see the ones that are used for checkers as animation again. 3535. So what if I return a different value? I'm tired of that randomization thing. Let's restart this. Okay. Let's try cleaning up my console by not printing that warning, first of all. All this console spam really slows down the browser. Okay, so 0, 1, 2, 3, 4, 5. So now we're going past what it's expecting. It's all the way over there. So yeah, that's the sprite that was just those two 0x60s. It's a little square, and it's just randomly moving around. Alright. That was fun. There's a bunch of other places it's using this random number generator, though. Okay, so that does seem to be only used for checkers, this random XY. So we have the checkers animation, we have randomized objects. There's a few other big functions here. This seems to be randomizing a limit of 100. Bunch of tables. Oh. Bunch of zeros there. What is going on here? This is a recursive function. Seems like it's got another entry point over here. This is calling random number with limit until it gets something that matches this. It's weird. What is going on here? Oh, it wants a random number that's different from what it's already got. It's retrying if it's a match. Are these robot room numbers? This is in the computer center level, I think. Yeah. Gosh, what could that be? This is something that chooses robots randomly, maybe, in the computer center? That is pretty weird. Huh. This too, it doesn't seem to be using the result here. It's more like a random chance. Just checking whether it's 0. It's got a random chance of moving the objects between rooms. I wonder if this is how the minefield works. Oh. A lot of interesting game logic in here. More random sprite drawing. Oh! Random sprite drawing does occur at a few places in the game. There's like a stream of garbage that happens in both, actually 2 levels, in the sewer and then later in the skyways. What level is that? But these could be special purpose rendering functions for those rooms. So like this might be checking like if you're in a particular room and then drawing some sprites. Is this looking up the address of a sprite? Yeah. And this is any sprite, like a limit of 3F. That's the whole space of addressable sprites. That's interesting. This is probably one of their garbage rooms. Could we go to one of those places while we've got this random number hook loaded? We can get to one of those pretty easily because it's actually in the sewer. The other one is kind of later on. But I might have a saved game in that area. Let's put the version of this back with the print so we can see what's going on. Oh, maybe joystick doesn't work in incognito mode. Oh, whatever. Okay, well, I was hoping this would involve some random sprite rendering, but maybe not. Or at least maybe random choices when the new sprites come onto screen, but... So like, anytime you call this, it should issue some text to the console. Let's see if I have any save games that might expose other instances of this. Which world is it? Huh. We sure are creating a bunch of random numbers. Are we waiting for the random number to hit a particular value? Is that what's going on? Console's very slow now. Yeah, this is... I don't know whether this is just something breaking in a different way or not. Let's just restart this. Okay. World 2. World 3. World 3, this is the right world. Where was I going? Oh, we're getting random numbers here for generating. That's interesting. Are we generating coordinates for the magnetic storms? Because we're only getting magnetic storms in the lower left corner of the screen now. Let's try returning a different value. Yeah. So that's an initial position, maybe even a speed for these solar storm or magnetic storm things. Yeah. I wonder if it's obvious from the disassembly which one that is. If there's a call that's specifically limiting to 100 and calling it several times. Oh yeah. Call this randomly launched magnetic storms. Okay, that's cool. That wasn't quite what I was looking for, but that's kind of neat too. That was the chippy thing. Oh, yeah, this is definitely a fountain of randomness going on here. We've got a bunch of different limits, and it's completely messed up now that I'm giving it a constant return value. Yeah. Oh, and my console is so slow. Okay, so we got limits of 7, 63, 72, and 48. So I think 7 is the color, 63 is the sprite number, and then the other two are X and Y coordinates. And it's just calling this a bunch of times per frame. Okay, can I, oh gosh, can I have a version of this that doesn't print? Okay. Great, so now we've got just a... Oh, that was weird. Okay. Okay, so this is a real object right here. This is an actual thing that exists. This is an actual key card that you can use to actually open the elevator. That thing in the bottom left corner is a sprite that I'm rendering at 0, 0 in color 0 with sprite number 0. And that just happens to be the player, and sprite slot 0 happens to keep getting rewritten with the walk cycle. So that's why it's like a copy of my player's walk cycle now. I could actually do something a little different if I, return a different value depending on what the limit is. But right now I'm giving it one value that it's using as a sprite ID, an X coordinate, a Y coordinate, and a color. So now it's subway token, exit ticket, Yeah, and this is all just by supplying different random numbers or number results. So what if I use JavaScript's random number generator? So this is like between 0 and 1, right? So then I would have to multiply it by the limit and then cast it to integer. I think that might need to go one higher too. This is not great, but it's better than their version. Let's see what it looks like. That's basically the original effect. We could double the limit and it should take up twice the space on the screen and half the sprites will be broken. That's about right. Or have it. Okay. That's cool. I think that's about the milestone I wanted to reach on this stream, was just having approximately this level of understanding of the random number generators in this game. So yeah, it's a really, really basic 8-bit linear feedback shift register random number generator. And it just uses it for simple stuff like making sprites move around randomly and putting the items in random spots when you start the game. But because it's just a pseudo-random number generator and it gives you deterministic results, the missing piece that I was kind of interested in figuring out at the beginning of the stream was like, how does it actually know when to be randomizing and when to sort of lock in the choices? And the answer to that turned out to be based on when you move beyond those first 2 rooms in the game. So it's pretty cool. Let's check in some of these changes, but not all of them. I think these changes in notes are good. Oh yeah. Okay, now this is what I don't want to save. This is the patch that we were using experimentally to extract the random number generator into our own thing. I don't know, it's like kind of an interesting toy to keep around. Maybe I'll put that in fun things to do for the moment. Yeah, that's pretty neat. Hold on to that. Oh, actually, I want to save this part too. Alright. So that didn't really change anything that should affect the real site, so I'm not going to bother deploying anything, but if you go to the Git repo, you'll see the new widgets. Alright, well, I think that's it for today. Thanks for tuning in if you were watching. Sorry Tuco was hanging out upstairs. I swear he looks super comfortable. You'll have to take my word for it, but he's really, really enjoying my pile of laundry and making sure it's all evenly coated in cat hair. So, yeah. Happy hacking, folks. We'll see you all next time.